Please don't.
Don't do it.
Please don't.
Don't do it.
Please don't.
Don't do it.
Please don't doubt me, cause I know what's happening. Please don't doubt me, cause I know what's happening. Turn my mixed numbers into improper fractions. Multiply my whole number to the denominator. Then I take that and add it to my numerator. Cross divide diagonal numbers by the AGCS. Replace them with the quotient, then I do the rest. Multiply my numerators, then I multiply my denominators. I take that answer, then I simplify it. Did it so fast that I don't know where the time went. Last step, check that my answer is accurate. Call this like work when I'm multiplying fractions. Please don't. Please don't. Please don't. Please don't doubt me, cause I know what's happening.
What's up, scholars? This is Mrs. Finney with Lyrical Math. This is our track tutorial for our song, Please Don't. This track covers the math concept for multiplying fractions, and what you just heard are the steps to procedurally solve for any multiplying fractions problem. The learning objective for this song is for you to practice reciting and memorizing those steps so that you can multiply fractions at any time. Let's get it popping.
Please don't.
Don't do it.
Please don't.
Don't do it.
Please don't.
Don't do it.
Please don't doubt me, cause I know what's happening. Please don't doubt me, cause I know what's happening. Turn my mixed numbers into improper fractions. Multiply my whole number to the denominator. Then I take that and add it to my numerator. Cross divide diagonal numbers by the AGCS. Replace them with the quotient, then I do the rest. Multiply my numerators, then I multiply my denominators. I take that answer, then I simplify it. Did it so fast that I don't know where the time went. Last step, check that my answer is accurate. Call this like work when I'm multiplying fractions. Please don't. Please don't. Please don't. Please don't doubt me, cause I know what's happening.
All right, let's jump into this example. We have 3 1/3 times 2 1/4. And using the lyrics, what we're going to do is say, please don't doubt me because I know what's happening. Turn my mixed numbers into improper fractions. Both of these are considered mixed number fractions. What in the world is a mixed number fraction? A mixed number fraction is where you have a whole number with a proper fraction. So here, 3 will be considered the whole number. 1/3 will be considered the proper fraction. This represents 3 whole pieces and then a whole piece that's split into thirds, but only one piece is included. So this is 3 1/3, a mixed number fraction. 2 1/4 would be 2 whole pieces with another whole piece split into fourths, but we're only using one of those 4 pieces. All right, so visualize that. We want to change these mixed number fractions to what we call improper fractions. What is an improper fraction? An improper fraction is when you have a numerator greater than a denominator. Let me give you an example. 10 thirds would be considered an improper fraction. The numerator is greater than the denominator. We could also have something like 9/5. Numerator greater than the denominator. So what we want to do for step 1 is change our mixed numbers into improper fractions. And the way we do that is we multiply our whole number to the denominator, then I take that and add it to my numerator. So in this case, we're going to do 3 times 3, which gives us 9, and 9 plus 1, which gives us 10. So we have 10 thirds, okay? What I also want you to see is that this actually represents the same amount, all right? But these are just 2 different names for the same thing. They just split a little differently here. Let me show you exactly what I mean. So we have 3 whole pieces, and this is a 4th whole piece. In this example, we have 3 whole pieces, shaded, and a third of a 4th one. So this is 3 wholes and 1/3. We change this to what we call an improper fraction simply by splitting the 3 whole pieces into thirds. Watch what happens. So we still have the same amount, but this is just like taking a pie of pizza and then splitting the pie into 3 equal parts. Notice here we're still looking at the same amount. It's just these whole pieces are now split like this one was. All right, so watch what we have here. 3 1/3 is equal to how many thirds? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 thirds. 10 thirds. Okay, so what we just did, we gave a different name for the same thing. All right, this is kind of like if somebody's name is Jonathan, they might call him John. Get what I'm saying? Same person, different name, same person. Different name, same amount. All right, we're going to do the same thing here. 2 1/4. We want to change to an improper fraction. So we multiply our whole number to the denominator. 2 times 4 gives us 8. Then I take that and add it to my numerator. 8 plus 1 gives us 9. So this becomes 9/4. What you notice is the denominators stay the same. So we had thirds here, we have thirds here, we have fourths here, we have fourths here. Step 1 is done. Multiply my whole number to the denominator, then I take that and add it to my numerator. Next step, cross-divide diagonal numbers by their GCF, replace them with the quotient, then I do the rest. So, in this case, we need to look at the diagonal numbers. So 10 is diagonal from 4, and 9 is diagonal from what? 3. Good job. So over here, I'm writing 10 and 4 because they're diagonal from each other. We're going to work with them. And I'm writing 9 and 3 because they are diagonal numbers. We're going to work with them. The lyric says cross-divide diagonal numbers by their GCF. What is a GCF? GCF stands for greatest common factor. A factor would be the numbers that multiply together to give you a particular number. So that would be, in this example, think of 2 numbers that multiply together to give you 10. 1 times what gives us 10? 1 times 10 equals 10. And we have 2 other factors for 10. 2 and what? 5. All right? So 1, 2, 5, and 10 will be called the factors of 10. Let's look at our factors of 4. 1 times what gives us 4? 1 times 4 equals 4. And we have one more number when we multiply it to itself. It also gives us 4. What number is that? Good job, 2. All right. Now, in the lyrics it says cross-divide diagonal numbers by their GCF, their greatest common factor. What is the greatest common factor? What is the factor that you see on this side and this side that both of them have? The greatest common factor. Did you say 2? If you did, outstanding. All right. So we're going to divide these diagonal numbers by their GCF, which is 2. So I'm just going to jot down the GCF of 10 and 4 is 2. All right. So 10 divided by 2 gives us how much? 10 divided by 2 equals 5. Or we can say how many groups of 2 can I get out of 10? 2, 4, 6, 8, 10 gives us 5. So we're going to cross out that 10 and make it a 5. That is called the quotient. Keep in mind the quotient is the answer to a division problem. We just did 10 divided by 2 and we got the quotient 5. Let's do the same thing here. How many groups of 2 can we get out of 4? Or what is 4 divided by 2? 2. So we can do 2, 4, get 2, or we can say 4 divided by 2 equals 2. Cross out that 4, make it a 2. All right, look at the other diagonal numbers. We have 9 and 3. What are the factors of 9 and what are the factors of 3? 1 times what gives us 9? 1 times 9 equals 9. And a number times itself also equals 9. What is that number? What is that number? I think you know. I think you know. What is that number? Did you say 3? Good. All right. And we have 2 factors for the number 3. 3 is considered a prime number. Just a side note. Prime numbers are numbers that only have 2 factors, 1 in itself. So the factors of 3 would be 1 and 3. Do you know what these other numbers are called? If a number has more than 2 factors, it's called a composite number. All right. So what is the GCF of 9 and 3? Look very closely. The greatest common factor. So I'm going to write the GCF of 9 and 3 is, drum roll. Did you say 3? Nice work. Good job. So cross divide diagonal numbers by their GCF. Replace them with the quotient, then I do the rest. So 9 divided by 3 gives us 3. Cross out my 9, make it a 3. 3 divided by 3 gives us 1. Cross out my 3, make it a 1. Good job. Step 2 is done. Step 3 says multiply my numerators. That's the top part of the fraction. Then I multiply my denominators. That's the bottom part of the fraction. That is so easy. What is 5 times 3? 15? Outstanding. Bring down some confetti. It's a party. We know our stuff. We know our stuff. So we're going to put 15 here for our numerator. Then I multiply my denominators. What is 1 times 2? Booyah. It is 2. Nice work. Step 3 is done. Easy, right? Step 4 says I take that answer, then I simplify it. Did it so fast that I don't know where the time went. We want to simplify this answer. And so this currently looks like what kind of fraction? An improper fraction. Yes, yes, yes. We want to simplify this. If you have the numerator larger than the denominator, once you get to your answer, you want to simplify by dividing the numerator by the denominator. So over here, I'm going to imagine I have a little scrap paper, and I'm going to set up the numerator divided by the denominator. How many groups of 2 can we get out of 15? We can count by 2. Make sure we do not pass 15. Keep in mind the cover-up strategy. Slide over till you see a number that is larger than the divisor. So 1 is not larger than the divisor, but 15 is. How many groups of 2 can we get out of 15? If I look at my answers to my 2 times tables, we want to keep going down and make sure we do not pass 15. We would stop right here. That's how many groups of 2? 1, 2, 3, 4, 5, 6, 7 groups of 2. Give me what? 14. 15 minus 14 gives us 1. Final answer. Start at the top. Go around the clock. We have 7 and 1 over 2. 7.5 as our final answer. Last step, check that my answer is accurate. Call this light work when I'm multiplying fractions. Please don't. Don't do it. Please don't. Don't do it. Please don't. Don't do it. Please don't doubt me because I know what's happening. All right, thank you so much for joining me for this track tutorial. I will see you at the next track tutorial. Stay awesome. Peace.